All right, so it was 5B was connected to 5A. So we had the same triangle, same given information. The only difference is we have a different question, right? We're bringing in area now. So because we're bringing in an area and we want to know about the rate of change of area, we're going to use area formula for triangle, which is either 1/2 base times height or base times height divided by 2, whichever one you want, okay? So that's the area. I used x and y just because I was using x and y earlier, so just to keep everything the same, I used x and y. So the next step is I need to find derivative of it, okay? So step 4 we didn't do. We're going to do step 4. We'll do some problems with step 4, and I'll show you why they're different. But for right now, step 5, find the derivative, okay? So the derivative of area is d capital A over dt. And then it's 1/2. So you could do it a couple different ways. I'm going to do it this way. You don't have to do it this way, but I'm going to do it. I'm going to go 1/2 times because it's really 1/2 times both. So x times y, to do that, you're going to need the quotient rule or the product rule. So product rule says the first x times the derivative of the second, which is dy over dt, plus the opposite, the second times the derivative of the first. Okay. Step 6, plug in what we know, substitute what we know. Well, we don't know dA over dt. I don't know that, so that's going to stay dA over dt. 1/2. X I know is 15 times dy over dt was negative 2.25, which we figured out in the last problem. Y is 20, and dx over dt is 3, positive 3. Okay. So we get 1/2, and again, for this section, you can use calculator. Let's see, so 15 times negative 2.25 is negative 33.75. Negative 33.75, and then 20 times 3 is 60. So 60 plus negative 33.75 is 26.75. Divided by 2. 13. What's that?
26.25?
75, sorry, 75. Or 25, no, you're right. Yeah, 25. Yep. 26.25, because this is supposed to be 25. And then 1/2 is going to be 13.125. Two things. It's an area, so squared, so feet squared. But it's also a rate, so it needs a over time. Okay. All right. All right, so that's finishing off that one. So next one, number 6. So the only difference with number 6 and the ones we've done before is its volume. It's the same thing. Doesn't matter if it's area or volume, you're still going to use the same steps. Okay? So it's a sphere. Radius of a sphere. Okay? So it's still, radius is from the center to the edge, just like a circle. Okay. All right. So this is the radius. And they give you the formula here for volume of a sphere. Okay. Okay, so the radius is increasing at a constant rate of 2 meters per second. At the instant when the radius is 5 meters, what is the rate of change of volume? Okay, and then the volume, and then round your answer. Okay, formula for volume, and then round your answer. All right, so what do we know? What have they given us? What do we know about the sphere?
We've got the radius.
Radius is 5 meters.
And that is increasing at 2.
So it's increasing at 2, right? 2 meters per second. So how would we write radius of the sphere is increasing at 2? What would we write on the other side? D R over dt. Good. dr over dt. And I think that's all we know. Okay? So what do we want to find out? What is the question asking?
The volume.
What is the volume, right? Sorry, not the volume. What is the rate of change of the volume? Rate of change of the volume. So how do we write that? That's going to be a question mark. But how do we label that?
Would we use capital V or?
Capital V, yeah. Yeah, for volume, area, you always use capitals. Yeah, so dV over dt is what we want. Notice it doesn't say anything about volume. Can we find volume with the given information? Yeah. Yeah, they give us the equation. We can do that, right? So if we need to do it later, we can do it. Okay. That's step 2. Step 3, now we need to come up with a formula that answers the question and involves what we know. Well, they've given you the equation, right? Volume. They ask us about volume, rate of change of volume, and we have enough information to find the volume. So that's going to be our equation or formula that we use. Next thing, derivative. D capital V over dt. So besides V, on the right side of the equal sign, how many variables do I have? So just just right there. Just R, right? R is the only variable. So if R is the only variable you're going to use, you don't have to use the product rule. You can just use the power rule. So we're going to move the power to the front, multiply it. So it's going to be 3 times 4/3 pi, that's the constant, times, reduce by 1, r squared. So 3 over 1 times 4/3, you can cross simplify, so it's just going to be 4 pi. So it's 4 pi r squared. Okay. Last step, plug in what we know. So I don't know dV over dt, that's what I'm trying to figure out. 4 pi r, we know r was 5, so 5 squared. Oh, wait, I forgot to put, sorry, go back a second. When I found the derivative, I took the derivative of r, right? So since I took the derivative of r, it needed a dr over dt, which I did not put. So make sure you include that. So the derivative should be dV over dt equals 4 pi r squared dr over dt. Bless you. I forgot to put that tag because I found the derivative of r. We don't know what dV over dt is, right? We don't know what that is, so that's going to be our missing, that stays missing. We get 4 times pi times r squared times dr over dt. R is 5. dr over dt is 2. So really you got 5 squared, which is 25, times 4 times 2. So 25 times 4 is 100, times 2 is 200. So really it's 200 pi, which we'd usually leave, but they said round your answer. So because they said round your answer, we're going to round it. Okay, so 200 pi, 200 times pi, where's pi? There it is, 628. They want us to round to the 3 decimal places. So 319, 319. That's a volume. So volume is cubed. So it would be meters cubed, and since it's also a rate, we got to give it a seconds. Meters is always cubed, and area is always squared. Okay. So number 7 is just a circle. It's just the two, so it's like number 4 and 5. So I'm going to skip number 7 for right now. Let's go to number 8, another 3-dimensional object. Let's do another, since we haven't done we've only done, this is our first 3D one. Let's skip 7 and go to 8. 8's another 3D shape. Cylinder. Okay. So cylinder is just like a can. When I think of a cylinder, I think of a soda can, soup can, whatever you want to. Okay. Still has a radius. The radius goes from the circle to the edge. And then this one has a height as well. Height is how tall the can is. The radius is the center of the top. See if I can here. Like the circle's on the bottom. So from the center to the edge, that's the radius. And then how tall the can is the height. Okay? All right, so let's write down what we know. The height of the cylinder is decreasing at a rate of 5 centimeters per second. So how do we write that? I know it's going to be decreasing, so it's going to be negative, right? Negative 5 centimeters per second. What are we going to label that as, though? D what?
dr.
Not dr, it's d, it's height, right? So dh. Over dt. The volume, it remains a constant 162. Cubic centimeters, centimeters cubed. Now, not only did they give us the volume, but what else did they give us in that one statement?
It's always going to be 162.
So it's never going to change, right? So what is dV over dt going to equal?
0.
0. At the instant when the radius is 5, so r is 5 centimeters, what is the rate of change of the radius? So what is dV? Not dV. dr. They want to know, the question is asking, oh wait, let's not get to the question yet. We'll get to the question in a second. Okay, so before we get to the question, is there anything that I have not written down that I know? I put dH over dt. I put the volume. I put dV over dt, and I have R. Is there something that's missing that I might need down the road? Which letter is missing? I have V, R, and H. Which letter is missing? From my list here, from my list of things that I know. Which letter is not?
H by itself.
H by itself, right? So I don't know H by itself. Could I find out what H by itself is? Do I have enough information to find out what H by itself is? Do I know V?
Yeah.
Do I know R?
Yeah.
Then you can. All right, so we're going to use, so we know V is 162, right? Pi is just pi. We know R is 5 squared, and we don't know H. This is just the volume formula. So we get 162 equals 25 pi times H, because 5 squared is 25. Divide by 25 pi. I get H equals 162 over 25 pi. I'm not going to divide that and round that. The only time I want to round is at the end. Because if you start rounding too early, then eventually your answer is going to be off. So if you don't round to the very end, you're okay. So I'm not going to round this until the very end. Okay. Because even though it says round, I don't want to round until the end. Okay. Okay, so I know dH over dt, I know H, I know V, I know dV over dt, and I know R. And the reason I don't know dr over dt is because that's the question, right? The question is asking about dr over dt. Okay. So we're going to use volume pi times r squared times h. Okay. Derivative. So it's dv over dt equals, remember pi is a constant, pi is the coefficient, pi is not a variable. So they're actually both times pi, r squared and h, right? So I'm going to do what I did with the 1/2 earlier. Move it out here and then do the quotient or the product rule. Okay. So I'm going to do this. Okay. So product rule says the first times the derivative of the second. So the derivative of h is dh over dt. And then the second times the derivative of the first, 2r dr over dt. Okay. Plug in. The only one you won't be able to plug in for is dr over dt, because that's what we're trying to solve for. So dv over dt is 0, pi. R is 5, right? So 5 squared times dh over dt is -5 plus h. We found out h was 162 over 25 pi times 2 times r, which is just 5, times dr over dt. Okay, so I'm going to simplify in between the parentheses. So there's a lot of parentheses, but the outside parentheses I'm going to simplify. So I get pi. 5 squared is 25 times -5 is -125. I can't do much here. What I can do is you can multiply, so this is over 1 and over 1. So 25 pi. So 162 times 2 times 5. So 162 times 10 is 1,620 times dr over dt. Okay, so I'm going to distribute the pi to both. So it's going to be negative 125 pi plus, but when I distribute it to the other, it's going to be pi over pi. It'll be 1,620 pi divided by pi, so the pi's will cancel out. So it's just going to be 1,620 over. Okay, so that guy won't have 25 pi. He'll just have 25 on the bottom. Okay. All right. I want to get dr over dt by itself. So I'm going to add 125 pi to both sides. I have 125 pi equals 1,620 over 25 times dr over dt. Last step, I want to get dr over dt by itself. So instead of dividing by the fraction, I'm going to multiply by the reciprocal. So I'm going to multiply by the reciprocal, which is the same as dividing by the fraction. Oops, not 40. So these guys will make a 1. So it'll make 1 dr over dt, which is what we want. Now we get to use the calculator. Now what you're going to do is you're going to plug that into your calculator. Let's see what you get. Let's see, 25 divided by 1,620 times 125 pi, a little over 6. 6.060. Okay. It's a rate of a radius, right? So it's not going to be squared, it's not going to be cubed, it's just going to be centimeters per second. Okay. Okay. All right. Okay, so now with the last 1, 2, 3, I don't know if we're going to do all 3, but this is where step 4 comes in, the step that we haven't used yet. When do we use it? Why do we use it? We're going to figure it out right now. Okay. So it's the same steps, just in the past we've skipped step 4, and I'm going to explain why we can't skip step 4 for number 9. It'll become pretty obvious once we get to step 3, why we can't skip. Okay. All right, so we're back to 2 dimensionals. We got an area of a circle. So no sphere, cube, cylinder, we got 2 dimensions. Okay. Circle has a radius. Okay. All right, so let's write down what we know about this circle. The circle is decreasing, the area is decreasing, right? Area is decreasing. So that's d capital A over dt. Negative 135 feet squared per second. That's that first sentence. Second sentence, at the time when the area is 9 pi, so capital A is 9 pi, what is the rate of change of the circumference? So look at what they did there. What did they do there in the second sentence? At the time when the area is 9 pi, what is the rate of change of circumference? We had area, we were talking about area, and then they brought in circumference, right? Mm-hmm. The question has to do with circumference. Area of a circle is pi r squared.
Yes.
Circumference is just 2 pi r. Circumference, right, is the distance around. Circumference is a distance. So if I started at the top, walked all the way around the circle, how far will I have walked? That's circumference. It's kind of like perimeter for a circle. Area is how much paint would it need, how much paint would it need to paint it gray? Right, that's area, okay? So they've been talking about area. They gave me 2 things with area, and then they say, hey, I don't want to know about area. I want to know about circumference. So when that happens, that's when we have to do a step 4. Okay, so we'll get there once we get, let's get to step 2 first though. We haven't wrote down what we don't know yet. Or what's the question? What is the question saying? What is the rate of change of circumference? So how would we write that?
DC.
D capital C, yep. D capital C over dt equals question mark. I have 2 things going on. I have area of a circle. Area of a circle is pi times the radius squared. And I also have circumference of a circle, which is 2 pi r. Okay. The next step is get a formula that relates everything and answers the question. Which formula would I use that will help me answer the question? Area or circumference?
I feel like this is a trick question, I don't know why.
I feel like it's neither of them.
Well, what's the question? Let's go back to the question.
We're looking for the rate of change of the circumference.
Circumference, right? The question specifically talks about circumference. So which one does that cover? Area or circumference? Circumference. So that's the one we're going to need. We're going to need circumference, right? So circumference equals 2 pi r.
So I'm assuming in part 4, that's how we include the area into it.
So to find r, because we don't know what r is, right? We're going to have to use, yeah. That's where area is going to come in. Okay? But for right now, we got that. Let's find the derivative. Let's go through our regular steps and find the derivative. Okay, so dc over dt. Remember, there's only one variable here. It's just r. So it's going to be 2 pi times dr over dt. Do I know dc over dt? No, but that's what the question was asking, so that's not a surprise. 2 times pi, and I don't know, the problem is I don't know what dr over dt is either. The only way for me to get dr over dt, or anything with the radius, right, is to use the other formula, and that's what I'm going to have to do. Okay, that's what I'm going to have to do. So alongside, I'm going to do the same thing I did before, but for area. Same thing I did for circumference, I'm going to do for area. We've done this before. We did this earlier with d capital A over dt equals 2 pi r dr over dt. For today, I think we did. Okay. dA over dt, I do know, it's negative 135. Times 2 times pi times r. R I don't know. And dr over dt I still don't know. But can I find r? Do I have enough information to find r? Let's go back to the original. Area is pi r squared, right? Do I know area?
Yeah.
Yeah. So I can figure out what r is. 9 pi equals pi times r squared, right? divide by pi. Pi divided by pi makes 1. R is going to be 3. 3 feet. I can't do that to find dr over dt, but I can do what I'm doing over here to help me solve it, so it's going to be 3. Okay. dr over dt, again, I don't know. That's what I'm trying to solve for. So we get negative 135 equals 6 pi times dr over dt. Divide by 6 pi. We get dr over dt equals negative 135 over 6 pi. There it is. dr over dt was negative 135 over 6 pi. I'm going to move that guy, put it in where I was missing earlier. Negative 135. I'm not going to divide yet. I'm not going to round until the very end. Okay. So now I'm going to take my calculator. Let's see, 2 times pi times negative 135 divided by 6 pi. The pi's are going to cancel each other out, and you'll get negative 45. Circumference is a distance. It's like radius. It's like height. It's like any of those. So it's not going to be squared or cubed. It's just going to be feet per second.
Was fully expecting a decimal after that?
No, yeah.
No, 270 is a fun little number.
When the pi's canceled out, it wasn't. That's what caused it not to be a ugly decimal.
Oh, sure.
Okay, so that's when we have to do step 4. Step 4 is another formula, 2 formulas.
Hey, so we're not explaining it to them, right? We're not explaining it to people in this, right?
So,
Find it out themselves.
I see the formula.
so when do we use that? It's when you're reading a question and you're like, okay, so it's talking about something, and then the question talks about something else, right? We're doing this and we're saying, okay, area, okay, wait, circumference. That doesn't help, right? That's when we have to use both. If it talks about just one thing, area, then you just need area. But if it brings up another thing, like number 10. Let's look at number 10.
Oh, no.
Or, yeah, number 10. It's number 9 on mine. I don't know why. So we got a cube now. 3-dimensional. So what gives us away that we're going to have to use step 4 and have multiple formulas?
Talks about volume and surface area.
Then it throws in surface area at the end. It slides in surface area and said, oh, here. You know, we're like, where does surface area, where did that come from? That's when we have to use it. Okay, so cube. Okay. Thing about a cube is all the sides are exactly the same. So whatever one side is, you know all of them. Okay? So let's see. The volume of a cube is increasing at a constant rate of 88 cubic meters per second. Okay. dV over dt equals positive 88 meters cubed per second. At the instant when one of the sides is 2 meters, you can use S for sides or you can use X. Doesn't matter what you use for sides. We'll just use lowercase s for side. 2 meters. What is the rate of change of the surface area? That's where you're like, wait, you were talking about volume, now you're bringing in surface area. So what is the rate of change of surface area? So that's going to be dSA for surface area, capital S, capital A, over dt. That's what they want to know. Okay, so we're going to have two formulas here. First formula is volume. Volume, how do we find volume of a cube?
Width times length times height.
Yep, and they're all the same. For a cube, they're all the same, right? So it's really going to be S cubed. The other one is surface area. Surface area, so surface area is just the outsides. So if you had a box, it would just be the outside. It's like how much paper does it take to wrap a box, right? If I wanted to wrap a box, that's the area of the flat surfaces, area of the flat surfaces. So it's just 2 dimensions, 2 dimensions, 2 dimensions, and you add them all up, okay? The formula for that is, what was it, 6s squared, 6s squared. Because it has 6 sides and area of one side is just s squared. So 6 times s squared. Okay. So the first one we're going to use is the one that we need to answer the question, which is surface area, right? That's the one we're going to focus on, surface area. Right? So find derivative of that, right? So derivative of that would be dSA over dt. So we're just going to use the power rule. So 12s times ds over dt. Okay. I don't know what dSA over dt is.
We also don't know what the
Yeah, this one I'm okay with because that's what the question is asking, but I don't know what, I know what S is too, right? But I don't know what ds over dt is. I don't know what that is. So because of that, that's when our other formula is going to take over, because I do know that. So our other formula is V equals S cubed. So dV over dt equals 3s squared ds over dt. I know what dV over dt is, 88. I know what S is, 2. I don't know what ds over dt is, but I can figure that out because it's the only variable left. 88 equals, was that 12?
Mm-hmm.
Divide by 12.
Don't.
Yeah, so don't divide it, just leave it as a fraction. You don't even have to reduce it yet because this is not our final answer. You're only required to reduce final answers, and this isn't our final answer. This is just part of the answer. That we're going to plug in right there. So 88 over 12. No? Calculator time. 12. The 12s are going to cancel out, actually. 12 times 2 times 88 over 12. You get 176. So it's area, surface area. So area is squared, so it's going to be meters squared per second. Okay,
How fun.
very fun. Okay, so do the last one on your own. Do number 11 on your own,
Go on.
and we'll call it a day. Okay. So volume, they say the volume is decreasing. The rate of the change of volume is decreasing by negative 131 feet cubed per second. Radius is 2. We need to figure out how fast the surface area is changing then. So we have two formulas, surface area and volume. Surface area is the one we want to use because that's the one that's what the question says. But we have to use volume because we don't know what dr dt is. So we just plug in, you do your derivative of dv dt, plug in what you know, and then you get derivative, or dr over dt is negative 131 over 16 pi. Plug it in, and you get negative 131 feet squared per second. And that's it.
I was really spooked when I got 16 pi for both sides. I'm
Yeah.
like, wait a minute, am I doing this right?
No, they cancel out nice and